It's hard to miss how AI is creeping into more and more of what we do.
Yeah, definitely.
From suggesting our next purchase to, powering sophisticated tools at work. It feels like the AI revolution is really picking up speed.
It really does.
So for this deep dive, we're going to give you a clear, jargon-free look at the current AI landscape, what's really important to know without getting bogged down in the super technical stuff.
Exactly. Today we're going to focus on understanding the core differences between the, let's say, workhorse of AI, what we call classic AI or applied machine learning, and the exciting new world of generative AI or Gen AI.
Okay.
We'll explore what each is best at, how they're creating real business value, especially in the telecommunications world, telco.
Right.
And then touch on some of the practical things to consider, like getting good performance without, breaking the bank, the best ways to approach AI projects, and even the impact on data, people, and, well, the environment.
Sounds good. You've looked at quite a bit of info for this.
We have, yeah. We've looked at a lot of information to try and bring you the most usable insights.
Okay, so let's start with the basics then. Classic AI, applied machine learning. What's the key difference from all the Gen AI talk we hear these days?
Okay, think of classic AI as your super accurate prediction machine. It's incredibly good at looking at past data to forecast what might happen next with a high degree of reliability. In the telecom industry, that translates to things like predicting how much network capacity will be needed or identifying which customers are likely to switch providers. It's all about spotting patterns and making informed predictions.
Got it. So
Yeah.
classic AI is the reliable forecaster. And where does Gen AI come in? What's its superpower?
Gen AI is your creative powerhouse. It excels at generating new content, whether that's text, like, drafting documents or even creating marketing materials or images.
Yeah.
It's also the engine behind those more advanced chatbots and virtual assistants that can have much more natural and, well, engaging conversations.
So one's about predicting the future based on the past, and the other is about creating something entirely new. It sounds like they could be a pretty powerful team.
Absolutely. In fact, what we're seeing in many industries, especially in telco, is that the most impactful solutions often come from a blend of these two approaches, a mixture of experts, if you will.
Ah, right. Mixture of experts.
Yeah. For example, you might use classic AI to predict a potential network outage.
Okay.
And then use Gen AI to automatically generate, say, a customer service message explaining the situation.
That makes perfect sense. So it's not about choosing one over the other necessarily.
Not usually, no. It's about synergy.
Now, beyond classic and generative, are there other types of AI that are important in the telco world?
Yes, definitely. We also have optimization and simulation techniques. These are really valuable for making things more efficient, like managing inventory or finding the best routes for network traffic.
Okay. Efficiency boosters.
Exactly. Then there are rule-based and more specialized AI systems, which are often used for making complex decisions and in autonomous systems where clear, logical reasoning is key.
So a whole range of AI tools in the box. But it sounds like for some specific tasks, maybe the more established methods still have an edge.
Exactly right. When it comes to things like categorizing network data or classifying customer issues, traditional machine learning techniques often provide more consistent and dependable results.
Right. Reliability is key there.
And for spotting unusual activity that might indicate fraud or a security breach, what we call anomaly detection methods, like, say, isolation forests and support vector machines, are still very effective. Proven techniques.
Okay, so we have this diverse set of AI capabilities. Let's talk about why this matters for businesses, specifically in telecommunications. How are these different types of AI actually, adding value?
Well, when you have a clear business problem, the right data to work with, and people who understand both the tech and the business.
Crucial combination.
Absolutely. Then applied AI can deliver really powerful, actionable insights. This gives companies a real competitive edge, letting them operate more efficiently, keep customers happier, and, ultimately improve their bottom line.
And how does Gen AI contribute to that business value for a telco? It's not directly about predictions in the same way, right?
Right. Gen AI opens up exciting new ways to generate revenue. Think about creating new products and services, especially in the whole telco media and entertainment space.
Ah, TME.
Yeah, this could involve things like personalized content recommendations, maybe more immersive interactive experiences, entirely new forms of digital engagement.
You mentioned some specific wins from these TME AIX projects earlier. What kind of results do they actually see?
Those projects, they achieved significant progress in areas like detecting and preventing fraud, which obviously saved them a lot of money.
Big impact.
Huge. They also got much better at predicting and preventing customer churn, which is crucial for retention. And they significantly reduced the MTTR, the mean time to resolution for network issues.
Meaning less downtime for users.
Exactly. Less disruption, happier customers.
Those sound like pretty significant improvements.
Right.
And you mentioned something called AIPI. What's the potential there? That sounds interesting.
AIPI, yeah. Artificially Intelligent Platform Interface. It's a really interesting opportunity. It essentially lets telcos offer their network capabilities as on-demand services through APIs.
Okay, so like network as a service.
Kind of, yeah. Imagine other businesses being able to tap into the telco's network for specific needs. Maybe a hospital needs guaranteed low latency for a critical application, or a manufacturer needs a secure, dedicated network slice.
Right, very specific needs.
And telcos can then monetize these services, maybe on a pay-per-use or subscription basis.
So it's like turning the network itself into an intelligent, programmable service. That's quite a shift in thinking.
It is.
But it sounds like the focus shouldn't just be on having the latest AI shiny object.
Exactly. You hit the nail on the head. The real measure of success for AI adoption should be the positive impact it has on the customer experience.
Okay.
If the tech doesn't ultimately lead to happier, more satisfied customers, then you're probably not focusing on the right things. It's not just about buying hardware.
Okay, so we understand the different types of AI and their business value.
Sure.
Let's get into the specifics. What are the most impactful ways AI is being used in telco right now? You mentioned classification earlier. Can you give us some concrete examples?
Certainly, classification is all about automatically categorizing data. In telco, this is incredibly useful for things like sorting different kinds of network traffic for billing and management purposes.
Okay.
Another key application is filtering out malicious traffic during a DDoS attack, protecting the network from being overwhelmed.
Like all stuff.
Absolutely. In those TME-AIX projects we looked at, we saw how algorithms like balanced random forests and neural network transformers were used to really improve revenue assurance and fraud management.
And prediction is another big area you said. What are some of the high-impact prediction use cases in telco?
Prediction is key for keeping networks running smoothly. Telcos are using it for service assurance, anticipating potential network problems before they actually affect customers.
Getting ahead of the game.
Exactly. Predictive maintenance is another big one, forecasting when equipment might fail so it can be fixed proactively before it breaks.
Ah.
Our work has involved using neural networks to predict things like network latency and even customer satisfaction scores like NPS. We've also used regression models to forecast energy consumption and more advanced techniques like T5 models to predict the operational status of 5G networks.
Wow, quite a range. So it's about getting ahead of potential problems. That's huge for reliability. What about segmentation? How is that being used effectively?
Segmentation involves grouping similar data points together. In telco, this helps in understanding different patterns of network usage. It can also pinpoint areas in the network that are, say, experiencing performance issues, hotspots.
Finding the trouble spots.
Exactly, and identifying unusual patterns, outliers, that might indicate a problem. We've even used techniques like density-based clustering to segment IoT device activity by time and location to identify potential security risks.
And we've touched on anomaly detection for security. Are there other critical applications for that?
Yeah, beyond just security and fraud, anomaly detection is also vital for spotting system faults. Think about identifying unusual behavior in network devices or detecting anomalies in smart grid operations, as we saw in some of our projects using sequential models.
It really sounds like AI is becoming deeply integrated into almost every aspect of how a telco operates.
Yeah.
What about how it directly impacts us as end users?
Well, that AIPI concept we talked about plays a big role here.
Right.
By intelligently managing network resources, it helps ensure that your applications, your streaming, your gaming perform well, even during peak usage times.
Okay.
It can also dynamically adjust security measures based on potential threats, all happening kind of behind the scenes without you even noticing.
So it's working in the background to make our digital lives smoother and safer. You also mentioned this idea of agentic AI that sounds a little futuristic.
It's definitely cutting edge, yeah. Agentic AI takes us closer to truly autonomous networks. Imagine different AI agents coordinating across various parts of the network, the radio access, the core network, the transport layer, and so on.
Okay.
coordinated agents.
Yeah, these agents can communicate with each other, diagnose problems collaboratively, almost like a team, and adjust their strategies in real time. This could lead to much more resilient and efficient networks in the future. This all sounds incredibly powerful, but it must come with a significant cost, right?
Mm-hmm.
Let's talk about the price and performance of these AI systems. What are the key things companies need to consider?
You're right. There's always a trade-off. One way to think about it is the balance between what we sometimes call the 3 A's: availability, accessibility, and affordability, versus pure processing power when you're choosing AI hardware, like GPUs.
The 3 A's versus power.
Exactly. In our Telco-AIX projects, for example, we found that using reasonably priced desktop GPUs actually gave us enough performance for the size and complexity of our data and models. Things like an RTX 4070 Super.
Really? So you didn't always need the absolute most powerful, most expensive hardware on the market.
That's right. We did experiment with higher-end GPUs, the big cloud instances, but we found that the much higher cost didn't always translate into a proportionally significant improvement in accuracy or reliability for our specific use cases.
Interesting.
It seemed like the data itself, maybe the quality or volume, might have been more of a limiting factor in those cases.
That's a really valuable lesson. Spending more doesn't automatically guarantee proportionally better results.
Yeah.
What about the energy costs associated with all this computing power? That's a growing concern.
Energy consumption is a huge consideration. The GPUs we ended up using had relatively low power requirements, TDP under 250 watts, which is important.
Yeah.
If you're using more powerful hardware, those big A100s or H100s, you have to think very carefully about the electricity needed and the cooling systems to manage the heat they generate.
Right. We talked about that before, how heat impacts performance and lifespan.
Exactly. As we discussed in a previous deep dive, excessive heat can really impact the performance and lifespan of AI accelerators. Thermal throttling, degradation, it's all connected.
Right. You can't just ignore the physical infrastructure demands.
Yeah.
You also mentioned something called the LLR pyramid. Can you explain that concept?
Yeah, the LLR pyramid that stands for latency, reliability, and redundancy. It's basically a strategy for deciding where to deploy different AI models based on their specific needs.
Okay, different tiers.
Kind of. At the top, in central data centers with tons of computing power, you might put the most demanding models, like the big foundational ones, GPT-4o or similar.
Got it. The heavy lifters.
Exactly. In the middle, maybe at regional data centers, you could have more specialized models, domain experts that need lower latency than the central DC, but still need decent power. And at the bottom, closer to the users at the edge of the network, you'd have lightweight models for tasks where speed and low latency are absolutely critical.
So it's about distributing the AI capabilities strategically across the network infrastructure. And you mentioned a specific technology for deploying these models efficiently.
Yes. For on-premises deployments especially, we found VLLM to be a really effective serving technology.
LLM.
Yeah. It's very efficient with memory, using techniques like page attention, which is crucial when you're running these large models. And it can handle high volumes of requests, high throughput, which is obviously important in a busy telco environment, especially when dealing with those mixture of experts models we talked about.
Okay, that makes sense for managing resources efficiently. So we've looked at the different types of AI, their value, use cases, and the hardware considerations. Now let's talk about how to actually do this well. What are some best practices for implementing AI in telco?
Well, the foundation, really, of any successful AI project is good data and sound data science practices. It always comes back to the data.
Garbage in, garbage out.
Exactly. Think of it like that data to wisdom pyramid. You start with raw data, then you process it to get information, then you analyze that information to gain knowledge, and finally, you apply that knowledge to get wisdom and make better decisions.
Right.
And for that, you need skilled data scientists who really understand the telco business, not just the algorithms. They need to be able to frame the problem correctly, prepare the data properly, choose the right AI models while considering that cost and performance balance, interpret the results accurately, and then, crucially, plan how to act on those insights.
It sounds like the human element is just as important, maybe more important, than the technology itself.
Absolutely. Couldn't agree more. And while there are many frameworks people use for AI development, we often find ourselves going back to the CRISP-DM methodology. Yeah, the cross-industry standard process for data mining. It provides a really solid, proven roadmap for successful data science and AI projects. It's been around a while for a reason.
Okay, CRISP-DM. What are the key steps in that process? Can you walk us through it briefly?
Sure, it's essentially a cycle with 6 main phases. First, and maybe most importantly, is business understanding, really nailing down the problem you're trying to solve from a business perspective.
Start with the why.
Exactly. Then you need to understand your data, what you have, its quality, volume, velocity, variety, all those V's, and its limitations.
Okay.
Next comes data preparation. This is often the most time-consuming part, cleaning, transforming, structuring the data for modeling.
Right, the heavy lifting.
Then you move into modeling, where you actually select, build, and test your AI models. After that comes evaluation, where you critically assess if your models are actually meeting the business goals you set out in the first phase.
Closing the loop.
Precisely. And finally, deployment, which is putting the model into production and, crucially, continuously monitoring its performance over time. That's where MLOps and machine learning operations comes in.
Right, it's not just deploy and forget.
Definitely not. And our TME-AIX projects have consistently followed this crisp DM approach. It provides that necessary structure.
That provides a really clear structure, yeah. Now, let's dive deeper into the data side of things. You've emphasized its importance multiple times. What kind of data are we actually talking about in Telco AI?
Well, like I said, the right data with the right features is what fuels these AI models. Without good, relevant data, even the most advanced algorithms won't be effective.
Makes sense.
In our TME-AIX projects, we've used a really wide variety of data sources. Things like OTel data open telemetry from cloud-native network functions, Prometheus exports for metrics, eBPF for kernel-level insights.
Wow, lots of operational data.
Yeah, lots of operational stuff, but also external data, like FCC open datasets, open weather datasets, even some classic datasets from places like UC Irvine's repository. You pull from everywhere you need to.
That's a lot of different kinds of data to wrangle. How does it all get used, especially in these newer systems?
In many advanced AI systems, particularly those that use something called embedding-based retrieval, like retrieval augmented generation, or RAG.
RAG, right.
Right.
Heard a lot about that.
Yeah. There's a specific pipeline for handling data. It usually involves taking documents or data chunks, breaking them down into smaller, manageable pieces, then creating numerical representations, vectors, or embeddings of that information.
Turning words into numbers, basically.
Sort of, yeah, capturing the semantic meaning. Then these embeddings are stored in specialized vector databases for really fast searching.
Okay.
When you ask a question or the system needs to find relevant information, your query is also turned into an embedding, and the system then searches the database for the data embeddings that are most similar mathematically.
So it's translating information into a language the AI can understand and compare effectively.
Yeah.
And you mentioned dynamic context assembly earlier. What's that all about? It sounds sophisticated.
It is a step up, yeah. Dynamic context assembly is a more intelligent way of providing information or context to the large foundation models. Instead of just blindly retrieving documents that seem related, the system first analyzes the user's query to really understand the intent, what's actually being asked. Then it strategically gathers bits of information from various sources, could be technical manuals, real-time operational data like MELT, customer history, regulatory guidelines, you name it.
So it pulls exactly what's needed.
Exactly. It assembles the most relevant and complete context for that specific query, which helps the foundation model generate a much more accurate and helpful response.
That sounds incredibly useful. Much better than just a document dump. Now, AI isn't just about the technology and the data. It also has a big impact on the people who work with it. What does the people side of the AI story look like in telco?
You're absolutely right. That's a critical piece. Successfully implementing AI requires not just new technology, but also significant changes within the organization and a real focus on developing the right skills.
Cultural shift, almost.
Yeah, it really is. It means breaking down those traditional silos between, say, networking, IT, and data science, and fostering much more collaboration.
Right.
We're seeing the emergence of new and really important skill sets or competency domains in AI-driven telecom. Things like foundation model operations actually running and managing these large models, telecommunications data engineering handling the specific data challenges in telco, AI integration engineering plugging AI into existing systems, and of course, AI governance and compliance ensuring responsible use.
Those sound like entirely new roles or significantly evolved roles for many telco companies. How are they adapting? How are they building these skills?
We're seeing different organizational patterns emerge. Some companies are setting up dedicated AI centers of excellence, like a central hub, to drive best practices and share knowledge.
Okay.
Others are embedding AI experts directly within different operational teams, so they're closer to the specific
A bit
problems.
more integrate.
Exactly. And to develop the necessary skills, companies are using a mix of strategies. Strategic hiring, obviously, forming partnerships with universities and tech companies, creating internal training academies, and even rotating employees through different AI-related roles to build that cross-functional expertise.
Yeah, so multiple approaches.
Yeah. There are definitely unique challenges for telcos in the skills transformation, given their legacy systems and specific regulatory environments, but there are also effective strategies for overcoming them. It takes commitment.
It sounds like a significant undertaking transforming the workforce alongside the technology. Now, let's consider the environmental impact. We touched on power consumption. What's the broader sustainability angle here with AI?
Yeah, the increasing demand for power from AI accelerators and the data centers that house them is a serious concern. Some projections are pretty stark, suggesting that global data center power consumption could double by 2030.
Double. Wow.
Yeah, which would require massive investments in new energy infrastructure, potentially straining grids. And as we discussed, these AI accelerators generate a significant amount of heat when they're working hard.
Right, the heat problem.
That heat can lead to problems like thermal throttling, where the chip slows down to avoid overheating, faster wear and tear on the hardware components, and, ironically, even more energy consumption needed for cooling systems. It's a bit of a vicious cycle.
So the more we rely on AI, the more energy it consumes and the more heat it generates, which can potentially impact its own efficiency and longevity. Are there other sustainability concerns related to the AI hardware itself?
Yes, there are. The intense computational loads can actually cause physical stress on the chips over time, leading to things like microcracks or electromigration, tiny physical changes that degrade performance.
Physical stress.
Yeah. Plus, manufacturing inconsistencies between chips, damage from static electricity during handling, and even inefficient software can also shorten the lifespan of this expensive AI hardware. And interestingly, while newer chip designs with smaller process nodes, like 4 nanometers, are more powerful, they also tend to concentrate more heat in a smaller area, increasing that TDP, the thermal design power.
It sounds like managing the energy consumption and the overall life cycle of AI hardware is pretty critical for sustainability then. What can telcos do about this?
Well, implementing good observability and monitoring systems is essential. You need to track how heavily the AI accelerators are actually being used, how much power they're consuming in real time, and their operating temperatures.
Data again.
Data again, exactly. And as we saw in the TME-AIX project work, making conscious choices about hardware choosing options that are more energy efficient for the required task, like those GPUs with lower TDPs, can make a real difference. It's about finding that sweet spot between performance needs and power consumption.
This is a really important aspect to consider as AI becomes even more prevalent. Okay, finally, let's zoom out a bit. How is AI evolving in the broader tech landscape, in business, and maybe even in our social lives?
Well, in the telco world specifically, we've seen a kind of evolution in adoption. It went from maybe relying heavily on external AI vendors in the early days to a push towards building more in-house expertise, and now maybe settling towards a more pragmatic, balanced approach combining internal capabilities with strategic partnerships and leveraging the best tools available.
Finding the right mix.
Exactly. There's also that ongoing discussion or debate even about the merits of open source versus proprietary foundation models. Many companies, especially in telco, seem to be leaning towards a hybrid strategy there too, using both depending on the need.
Right, not strictly one or the other.
And in how telcos manage knowledge internally, we've seen a progression from basic search tools to using RAG to deploying more capable models on premises, using that embedding-based retrieval and dynamic context assembly we discussed, with the eventual goal, maybe, of those more autonomous networks powered by coordinated AI agents.
It feels like we're still in the relatively early stages of figuring out the best ways to really integrate AI deeply into existing systems and workflows. You also introduced this interesting idea of AI rings earlier. Can you just remind us what that framework is about?
Sure. The AI rings framework is just a conceptual way to categorize different types of foundation models based on their capabilities, how they're typically deployed, and maybe their broader implications.
Okay.
So the one ring might represent the most powerful general-purpose AI models out there, like the absolute state-of-the-art. The three rings could be elite, often proprietary models from major players. The seven rings might be powerful models, but more specialized for specific domains or industries. And the nine rings represent those lightweight, efficient models designed to run at the edge of the network.
Got it. Different tiers of power and specialty.
Exactly. It's just a mental model. And this framework, maybe used alongside that LLR pyramid concept for deployment strategy, can help organizations make more informed decisions about which AI models are most suitable for their specific needs and constraints.
That's a really helpful way to think about the diverse landscape of AI models available. So as we bring this deep dive to a close, what are the key things people should remember when comparing classic AI and Gen AI, especially in the telco context?
I'd say remember that classic AI, applied ML, remains the go-to for accurate prediction and forecasting tasks where reliability is paramount. Gen AI, on the other hand, is your creative engine, excelling at content generation and more natural conversational interactions.
And often best used together.
Often, yes. The most impactful solutions will likely leverage the strengths of both, that mixture of experts approach. And we've seen how AI, both types, is delivering significant tangible business value in telco, reducing fraud, improving customer retention, enhancing service quality, lowering resolution times, and even creating totally new revenue streams through innovative platforms like AIPI.
And what are the most important AI use cases that are making a real difference right now?
Well, we're seeing significant impact in areas like automatically categorizing network traffic and detecting cyber attacks, that's classification, predicting network issues and potential equipment failures prediction, segmenting network data for better optimization and hotspot identification segmentation, and of course identifying anomalies to prevent fraud and system outages.
And ultimately, better service for us users.
Exactly. Ultimately, all of this contributes to a better, smoother, more reliable experience for the end user through more intelligent network management.
And the key takeaways regarding price, performance, data, people, and sustainability. What's the bottom line there?
I think it boils down to find the right balance between cost and performance for your specific needs. More expensive isn't always proportionally better. Ensure you have high-quality, relevant data that's non-negotiable. Invest in the skills and the necessary organizational changes required to implement and manage AI effectively. It's a people challenge, too. And finally, be mindful, increasingly mindful, of the environmental impact and energy consumption of your AI infrastructure choices.
So, as our listeners think about all of this, maybe reflect on their own work or industry, which of these AI rings or approaches do you think holds the most transformative potential for them? I feel like there's a lot to consider depending on your context.
That really is the key question for you, the listener, to explore further, isn't it?
Yeah.
Do you need the broad, overarching power of a one-ring model, or would a more specialized seven-ring tailored to your domain be a better fit? Could the speed and efficiency of a nine-ring model unlock new possibilities at the edge of your operations?
Lots to mull over.
Definitely. We encourage you to delve into some of the resources we've mentioned, like those open experiments repositories on GitHub, or maybe revisit some of our past discussions on related topics to explore the areas that resonate most with your interests or challenges. The world of AI is constantly evolving, it's moving so fast, and its impact across technology, business, and frankly, our daily lives will only continue to grow.